7. The distributive property. In this lesson, you learn to use the distributive property to simplify expressions. If you recall, in 1-6, we talked about properties of equality and different types of property in terms of the identity property and the multiplicative property of 0. Okay. In this lesson, 1-7, we only will discuss one property, and that's the distributive property. It gives you an idea how important the distributive property is in the scheme of things when you talk about all the properties. Okay, so let's begin. Let's talk about a real-world application in food service. In the school cafeteria, each student can pick one hot or cold entree and one salad from the following in order to get a meal deal lunch at a special low price. So you have hot lunch of tacos, meatloaf and mashed potatoes, steamed veggies, spaghetti, cold lunch submarine sandwich, turkey club sandwich, tuna salad with tomato. For the salads, you have tossed salad and you have fruit salad. Okay? Janine wants to know how many different lunches are possible. She can make a table to represent all the possible combinations. Okay? And this is what she got. For hot lunch, okay, entrees, tacos, meatloaf, veggies, and spaghetti, and salads, tossed, and fruit. Okay, and for cold lunch, these are the possible, okay, combinations. Hot lunch, you can do taco and tossed salad, meatloaf and tossed salad, tacos and fruit, meatloaf and fruit, veggies and tossed, and so on and so forth. Same thing with the cold lunch, submarine and tossed salad, club sandwich with tossed salad, tuna salad with tossed salad, submarine with fruit, submarine club sandwich with fruit, and tuna salad with fruit. Okay? And if you notice, there are 8 possible hot lunches, and there are 6 possible cold lunches. Okay? So, if you add them up, there are 2 times 4 plus 2 times 3 possible lunches from which students can choose. Okay? Note that 2 times 4 plus 2 times 3 is equal to 8 plus 6, or 14. Okay? Pretty simple analysis there. And let's figure out what it all has to do with the distributive property. Okay? Janine can also represent the problem by using the following table. Okay? And if you look at that table, you now have your entree, and hot lunch and cold lunch have been combined in one table. Okay? Tossed and fruit as well. And according to this table, there are 2 types of salads times the total number of entrees, 4 plus 3, or 7. 2 types of salad, types of entrees, 4 here. Okay, and this is where we're getting the 4 right here. Okay, these are your 2 types of salads, and these are your entrees, 4 and 3 is equal to 7. Or we can make the equation 2 times the quantity 4 plus 3, okay, equals 2 times 7, or 14. Okay, either way, you look at it, there are 14 possible lunches. That's because the following is true. 2 times the quantity 4 plus 3 is equal to 2 times 4 plus 2 times 3. This is an example of the distributive property. Okay, now why is this called the distributive property? We're going to talk about that soon too. But look how 2 has been distributed to 4 to make 2 times 4. And look at how 2 has been distributed to 3 to make 2 times 3. Which brings us to the distributive property for any numbers a, b, and c. A times the quantity B plus C will be equal to AB plus AC, and B times the quantity B plus C times A is equal to B times A plus C times A. And distributive property holds true for subtraction as well. Okay, so it will hold true for both addition, okay, and also subtraction. So that is now the distributive property, okay, in symbols. Okay, now in the distributive property, notice, okay, that it doesn't matter where A is placed on the right or the left side of the expression in the parentheses. Okay, the symmetric property of equality allows the distributive property to be written as follows. If A times the quantity B plus C close quantity equals AB plus AC, then A plus AB plus AC is equal to A times the quantity B plus C. Okay, I hope you remember this from the last lesson, and this is the symmetric property of equality. So they can be interchanged. Those are both distributive property. Okay, let's take a look at this example and see how this works. The Oak Grove High School Spirit Club wants to make a banner for the championship football game. Students have 2 large pieces of paper to use for the banner. One piece is 5 feet by 13 feet and the other is 5 feet by 10 feet. They plan to use both pieces for the banner. Find the total area for the banner. The total area of the banner can be found using 2 ways. Okay, the first method, okay, you have your rectangle, okay, and it's 5 feet by 13 feet, one piece of the banner. Another piece of the banner is 5 feet, 10 feet. So method 1 would be add the areas of the smaller rectangles. Okay, so we know for a fact that the area of rectangle is length times width. So we add width and length 1, which is 13 feet, plus width and length 2, which is 10 feet. So you now have 5 times 13 plus 5 times 10 will give us 65 plus 50, or 115 square feet. Okay, that's the total area of the banner. In method 2, multiply the width and the length. Okay, multiply the width and the length. So you now have the width is 13. Okay, the length is 13 plus 10 because of the length of the first banner plus the length of the second banner will give you 13 plus 10. Then multiply it with the width, which is 5, end up with 5 times 23, or 115 as well. So both methods work. The area is 115 square feet. Okay, let's take a look at example number 2. Use the distributive property to find each product. 7 times 98. Okay, this is very useful when you are trying to solve this mentally. 98 is the same as 100 minus 2. So 700 times 100 minus 2. Using the distributive property where you distribute 7 to 100 and 7 to negative 2. Okay, you now have 700 minus 14, or simply 686. In the same manner, you can do that with 8 times 6.5. 8 times 6.5 becomes 8 times 6 plus 0.05. Okay, using the distributive property, this becomes 48 plus 4. 8 times 6 is 48. 8 times 0.5 is 4. Simply add the 2, end up with 52. And that's how you use the distributive property. Okay, so moving on. A term is a number, a variable, or a product or quotient of numbers and variables. So that's the definition of a term. This should be written down in your notebook. Okay? A term is a number, a variable, or a product, or quotient of numbers and variables. Some examples of terms are x cubed, 1/4 a, 4y. The expression 9y squared plus 13y squared plus 3 has 3 terms, and these are your 3 terms. Okay? Like terms are terms that contain the same variables with corresponding variables having the same power. Okay? Now we define what like terms are and take note of these. They are terms that contain the same variables with corresponding variables having the same power. Okay? So in the expression 8x squared, let me remove the ink there. In the expression 8x squared plus 2x squared plus 5a plus a, 8x squared and 2x squared are like terms. Why? Because they have the same variable and they have the same exponent. Okay, the powers are the same. Same base, same exponent, like terms. 5a and a are also like terms because they have the same base and they have the same exponent, which is 1. Okay, so we can use the distributive property and properties of equality to show that 3x plus 8x equals 11x. And in this expression, 3x plus 8x are like terms. Okay, so using the distributive property, 3x plus 8x is the same as quantity 3 plus 8 multiplied by x, or simply 11x using the substitution property of equality. Okay, the expressions 3x and 8x are called equivalent expressions because they denote the same number. An expression is in simplest form when it is replaced by an equivalent expression having no like terms and parentheses. Again, I reiterate the meaning of the word simplest form is in an expression. Write this down, okay, somewhere, because this again becomes very important all the way to high school. It is in simplest form when it is replaced by an equivalent expression having no like terms and no parentheses. So that's when an expression is in simplest form, which brings us to example number 3 back down here. Okay, so let me light this up again. There you go. Okay, so in example number 3, you're asked to simplify 1/4 x squared plus 2x squared plus 11/4 x squared. Okay, if you notice in this expression, they are all like terms. 1/4 x squared, 2x squared, and 11/4 x squared are like terms simply because they have the same variable and their variables have the same exponents. Okay, simply add them. 1/4 plus 2 plus 11/4 multiplied by x squared using the distributive property, and using the substitution property of equality, 1/4 plus 2 plus 11/4 is equal to 5, and simply multiply that with x squared. Okay, so that is using adding like terms. Okay, coefficient, another definition that needs to be written down. You'll be carrying this with you all the way to high school again. The coefficient of a term is the numerical factor. For example, in 23AB, the coefficient is 23. XY, and in XY, the coefficient is 1. Since the multiplicative identity property 1 times XY equals XY, so whenever you have a variable that does not have a coefficient readily seen, example, if I have y, the coefficient of y will always be 1 because that's equal to 1 times y. Coefficient of x will always be 1 because that's 1 times x. Okay? Like terms may also be defined as terms that are the same or that differ only by their coefficient. So another alternative definition of like terms, they only differ by their coefficients. Okay, name the coefficient in this term. Pretty simple. 145x squared y. Coefficient, of course, is 145. In this case, the coefficient is 1, and for a squared over 5, the coefficient would be 4/5. okay, because 4a squared over 5 can be written as 4/5 times a squared, therefore it's 4/5. Example number 5, simplify each expression. You have 4w to the fourth plus w to the fourth plus 3w squared minus 2w squared. Okay, remember that w to the fourth is the same as 1w to the fourth, therefore it will have a coefficient of 1. Okay, and then therefore 4w to the fourth plus w to the fourth plus 3w squared minus 2w squared will be equal to, okay, 4 plus 1 using the distributive property, quantity 4 plus 1 times w to the fourth, again using the distributive property, quantity 3 minus 2 times w squared, okay, end up with 5w to the fourth minus 1w squared, or simplify that further, take that 1 out of there, 5w to the fourth plus w squared. Again, why is this in simplest form? Because remember the definition, an expression is in simplest form when there are no like terms and there are no parentheses. And in this case, there are no like terms and there are no parentheses. This is in simplest form. Letter B, a cubed to the fourth plus a 2a cubed. Okay, remember that a cubed over 4 is equal to 1/4 times a cubed. Okay, so a cubed over 4 plus 2a cubed will be 1/4 a cubed plus a cubed. We have like terms because a cubed, because they have the same base and their variables have the same exponents. So using the distributive property, we now have 1/4 plus 2 multiplied by a squared, or 2 and 1/4 times a cubed, and that is the simplest form of letter B. Okay, we reached the end of our lesson. On Google Forms, type a summary of what you've learned. Okay, a lot of terms that have been learned in this lesson, so write them down in your notebook. Those are important going forward in the future. Okay, and type a question you might want to ask in class about this lesson. Thank you.